of our radicand. So I just want you to think about these two fractions. How would you simplify them? What are you looking to do if you were going to simplify? First one, what would you do? You could divide by 3. Anyone see anything other than you could divide by?
Divide by 6.
Could divide by 6, could divide by 12, and you're dividing each one. How about as you look at that second fraction? 92 and 16. What could you maybe divide by first because you look at the last two numbers? You could start with 2, right? And then if you didn't recognize, you could keep going from there. So I just want you to take a look at this. So this is kind of leading us into simplifying our radicals. So what we did when you're simplifying these, you found a number that divided into both. If you're thinking about that, some of you told me when we started this first one, some of you said 3 or 4, or you're looking for numbers that divide into both, okay? So it divides into both evenly, both numerator and denominator. If you look at that first one, we could have said 3, but we could have gone further. In the second one, dividing them both by 4 maybe. So what you are thinking when you are doing these, and it doesn't matter if you divide by 4, if you divide by 2, if you divide it by 12. Here they said if we look at dividing these first by 4, some of you said I divided by 2. A lot of times when we're simplifying, we use our basic knowledge of multiplication tables that we memorize. You probably memorize those, some of you 3rd, 4th grade, some of you maybe before. But you use that information and you thought, oh, what do they have in common? That's where we're going with our square roots today when we are asked to simplify. So you were simply dividing these by a number. So this one would have been simplified. 1236 would simplify to what? 1, 4. Did anyone simplify 92 over 16? 1/3. 1/3. Excuse me. 1/3. 92 over 16? Anyone divide that one? We're dividing by 2 or dividing by 4. But again, it's just breaking it. How much? 23 fourths. Dividing by 4. And again, in simplest form, they have nothing in common, right, once we get to that. So we are going to keep breaking it down. And again, you could have gone by 2, could have gone by 4. There's many ways of doing that. When we look at simplifying our radicals, okay? So it says simplify these radicals while watching the video. And then we're going to kind of take a look at some notes from the video as to how we are always simplifying, okay? So as you take a look at this video, as you are taking a look at this.
How can we simplify a radical expression without an area model? In this lesson, you will learn how to simplify radical expressions by factoring. Let's review what a factor is. A factor is a divisor of another number. In other words, it can get multiplied into the original number without a remainder. For example, the number 24 has a lot of factors. All of these numbers will be divided and can be divided into 24 in these pairs without a remainder. Remember that the difference between rational and irrational numbers. A rational number is a number that can be written as a fraction of integers. An irrational number is one that cannot be written as a ratio of integers. It can be easily identified as a number that cannot be written with a repeating decimal. Remember also, a square that is 18 units squared has a side length of the square root of 18. The square can be divided into 9 squares of equal size, 2
kind of thinking back to
cubed
last
2
year when
units
you did some
squared.
work with squares.
The smaller squares have a side length of the square root of 2. Since there are 3 of the squares on the side, the side is 3 square roots of 2. So the square root of 18 equals 3 square roots of 2. But there has to be an easier way than drawing boxes. Let's take the last example. The square root of 18. You can decompose the radical into factored parts. You may have learned how to make factored trees. Now they can help you decompose this radical. The square root of 18 can be factored into the square root of 9 times the square root of 2. The square root of 9 can be factored into the square root of 3 times the square root of 3. All of these are prime factors that when multiplied together give the product of the square root of 18. We look at the square root of 3 times the square root of 3. Well, that equals 3. You can't simplify the square root of 2, so putting it all together, you get 3 square roots of 2. A quick and easy way when you're looking for a square root is to look for pairs.
So, as you are looking at this, you're going to write this down, and then they're going to give you some
like
hints.
The square root of 3 and the square root of 3. When multiplied together, pairs will always make perfect squares. Whatever's left after you take out all the perfect squares stays under the radical.
So, key thing when we look at this, you should write this right below that square root of 18. Square root of 9 times square root of 2. This step right here that they are doing, breaking it into your last, factors to give you 9, I would look at, you could go from this point, square root 9, right to the 3. And then since you can't find the square root of 2, it's not one that we know that we memorized, then you're going to leave it that way. Okay, so as you are looking at that.
Let's try another one. Square root of 24. You know that the square root of 24 has a lot of factors, but you want to find the prime factors. There are a lot of those too. Decompose the radical, the square root of 24, into its prime factors. The square root of 24 can be factored into the square root of 2 and the square root of 12. The square root of 12 can be factored into the square root of 4 times the square root of 3. The square root of 4 can equal square root of 2 times the square root of 2, which ultimately equals 2. What's left without a pair? You have a square root of 3 and another square root of 2. Putting it all together, you end up with 2 square roots of 6. You don't have to do factor trees to see the factors. Let's look at square root of 18 again. This time, write the factors under the radical. 9 times 2 can still be decomposed into 3 times 3 times 2. Since you are looking for a square root, you want to find a pair. Here you have a pair of 3's, so you still end up with 3 square roots of 2. But what if the numbers aren't in the right order? Let's look at the square root of 24 again. Write the factors under the radicals and this can still be decomposed into 2 times 3 times 2 times 2. Since you're looking for a square root, you want to find a pair. It doesn't matter if I use this pair of 2's or if I use this pair of 2's. Either is a pair that being multiplied ends up with 2. In the end, the square root of 2 times the square root of 2 equals 2, and what's left under the radical multiplies to equal 6. What if it's not a square root? Consider this time the cube root of 54. We write the factors of 54 under the radical, and we get the cubed root of 27 times 2. It can still be decomposed into 3 times 3 times 3 times 2. This time, you're looking for a cube root. Since a cube root is a number that is multiplied together 3 times, you want to find a triple. Under the radical, you can find a triple 3. So you end up with 3 cube roots of 2. If you know your roots, it's like a shortcut since you don't have to decompose your radicals down to the prime factors. Again, let's look at the square root of 24. You start with 6 times 4, but you already know that the square root of 4 is 2. You can take that out right away, and you end up with 2 square roots of 6. Now the cube root of 54. We know that equals the cube root of 27 times 2, but if you know that the cube root of 27 is 3, you're done much faster. In this lesson, you've only worked with irrational numbers that involve roots. One key point is that some numbers with a radical can be simplified into a rational number. The square root of 9, for example, can be simplified into the number 3, which can be written as 3 over 1. So it's a rational number. If you simplify a number as much as possible, and it cannot be written as a ratio of integers, then it's still irrational. In this lesson, you've learned how to simplify radical expressions by factoring.
So if we are looking at that, you should have had your answers for each of these. And if you were going to say what is the best way to kind of simplify, I want you to think about those ways that they showed you. We're always going to be factoring, but I want you to think. The hint is that one of the factor parts when you're doing square roots is find one of your perfect squares times that number. So if we are looking at a perfect square as one of our factors, as one factor. So finding a perfect square as one of your factors, and then you're going to have it times another number when we think about that. So if I think about square root of 18, and I think of that, my perfect squares, the reason we had those memorized is that's that list, 1, 4, 9, 16, 25, 36, right, that I'm listing. And if I look at that list and I go, oh, 9 times 2, and I go the square root of 9, as they were showing in that last part, times 2. So the square root of 9 times 2, we know you can always pull these apart. This is the square root of 9 times the square root of 2. And the square root of 9 is that 3 times the 2. So again, when you look at 24, and I know they said 6 times 4, I always like to put my perfect square first. So when I look at the square root of 24, I might start with the square root, and I'm going to go 4 times 6. Because there is not, if I go to 25, I know it has to be less than 25. 16 doesn't work, 9, so I go to 4. So again, if you can list those perfect squares today when you do your homework, that's a nice way of helping you out. But now I can think of it as the square root of 4 times that square root of 6, and that's how we got that answer of 2 square root 6, okay? Are there other ways of doing this? Yes, they showed in the video. You can continue breaking this down to always showing 2 things that are the same, and square root 2 times square root 2 is not equal to the square root 2. It does equal just 2. Or you can stop at this point and go from here. Same thing with our cube roots. So that's why I'm memorizing those first cube roots. And you might look at 54 and not realize it's 27. So again, if you're making a list of your cubes, you might list those and go, oh, I know it's 1, and then the next one is 8, and the next one is 27, and then the next one is 64. So if we're finding the cube root of 54, obviously 27 isn't going to, 64 isn't going to work, so then we might either try dividing it by 27, but we notice it's an even number, so dividing it by 2 might give you one of those factors, okay? So on the top of the next page, we are simplifying. It says, right, cannot be simplified if you can't simplify it. And so we want to start looking at that list of perfect squares. So if I'm looking at 48, so my hint is right now, let's make a list. Since all of these, or most of them are squares except the last 16. If someone would have picked out 16, theirs would have been the square root of 16 times what? 16 times what gives us 48? 3. If you pick a larger perfect square, there's always less simplifying. The larger the perfect square that goes into this number, the less you have to simplify. Here you're going to look at what's the square root of 4? 2. Square root of 4. 2 times square root of 3. Here you're going to be looking at the square root of 16 times square root of 3. To me, this one's a lot easier, but you have to recognize that 12 was not a perfect square and there's a perfect square that divides into it. Both answers are going to give us, if we are looking at this, 4 square root 3. If I'm looking at square root 42, let's do that one together and then I'm going to let you try some of them on your own. If I'm looking at square root of 42, perfect square that goes into 42. 1, 4, 9, 16. Do we have one? What gives us 42? 6 and 7. 6 and 7 aren't in my list, are they? So if we are looking at this, we are going to say it cannot be simplified. Because 6 times 7, that doesn't help us with getting rid of my square roots or my, you don't have a perfect square. How about 50? Perfect square that goes into 50. 25. So you're going to factor it as square root 25. And I don't care if you put them underneath that same radical, so 25 times 2, or if you think of breaking it apart as square root 25 times square root 2. Some of you will like to go that next step and put square root 5 times square root 5. Do you need to do that for me? No. At this point, you can tell me your answer is going to be square root of 25 is 5 square root 2. Okay? So I want you to try these next 3 and the bonus, and then we'll 20. So if I go with 4 and 45, I have 4, but 45, I can factor it further. What's a perfect square that goes into 45? 9 times 5, okay? So at this point, I have square root 4, which equals 2. I have square root 9, which equals 3, right? Square root of 9 is 3. And I have square root 5, which I can't simplify, 6 square root 5. If I do it this way with the 9, I have square root 9, and 20 can be factored how? 4 times 5, right? So I get the square root of 9 times the square root of 4 times the square root of 5. If you wanted to write it one more time, you could have said square root of 3 times 3, but the square root of 9 is 3. The square root of 4 is 2 times the square root of 5. The other way that Elena said she did, she went with the square root of 36 times 5. So if you look at this list of perfect squares and keep dividing, so if you did the 4 and got 4 and 45 or 9 and did this, this is going to be the quickest one. All answers are going to give us the same thing, which is 6 square root 5. Okay? So does it matter which way you do it of these three? Not at all. You will, some of you will easily pick out those perfect squares right away, the biggest ones. Some of you won't. If you don't find the biggest one, you just got to keep factoring. Okay, so keep using those multiplication facts that you know. All right, so square root of 98. Not sure, so I divided by 2, right? 2 times what is 98? 49. Oh, how beautiful is that, right? 49 times 2. So I have the square root of 49, and I usually put my perfect square first, times 2, because the square root of 49 is 7 square root 2. This is being multiplied. A lot of times they don't put that dot in there. Okay, so now we're looking at the cube root of 40. So again, with those cube roots, if you need to list those first cubes, right? So we have 1, we have 8, we have 27. Which one is it probably going to be? It goes into 48, right? So when we look at this, again, if it helps you to list those, we are going to have the cube root of 8 times 5. That means we have the cube root of 8 times the cube root, and you always want to keep your index of a 3 here, of 5. So finding that root of 5. The cube root of 8 is 2, and then you're going to have the third root with 5. Questions? So how do you do it when you get a variable? Okay? How do you do it when you're looking at a variable like x to the third? So you might want to think x to the third can be factored as x squared times what? Times x. So we really have the square root of x squared. What's the square root of x squared? What happens to these two things? They kind of undo each other, right? So this is going to be x times the square root x is our answer for this one. X times the square root of x. Okay? So we're breaking it down to x squared times square root x. Questions? We basically ignore the number in front until the end of the very problem. We simplify the radical part just like we did before, and then you multiply it by the number that's in front times that answer. So if you look at how they had 3 square root 50, they started off with 3 square root 50, they write 3. They're factoring the 50 is 25 and 2. Square root of 25 is 5 square root 2. We multiply 3 times 5 to give us 15 square root 2. So if we are looking at, this is really written as 4 times the square root of 28. What is a perfect square that goes into 28? So we're going to have what? 4 times, what do we have? 7. You see how it can't be 16? Yes? Okay. So 4 times 7. So I'm going to have 4 times, I have the square root of 4. I don't care if you write it separately like this, square root 7, Or if you go right to this step and say, oh, this is 4 times 2 times square root 7, which gives us 8 square root 7. Try the next one on your own. 9 times 5. So then you took what? 6 times. Did you go square root 3, square root 3, square root 5? Did you break it that one step further, or what'd you do to get your answer? So do you want me to write out, is it square root 3 or 3? What am I putting down? I'm not sure.
Square root 3. Square root 3. Square root 5.
Okay. Next up. I don't know if I would have gone this step, but if you do this and you write it out this way, what is square root of 3 times square root of 3? Yes, but what does that equal? Okay, so what I'm saying is you don't necessarily have to go here. You could have done this and said 6, and this is what I've seen on a lot of people's papers, 9, 5, and a lot of you went from this step to right here. If it helps you to write it out double like that, do it, by all means, always do that. And then we're left with square root 5. So if I'm looking at my answer, Jacob, what'd you end up with? 18 square root 5, okay? As you do the problems, please, please, please make sure you're checking as you are looking at those, okay? So, then we have some that get a little more interesting, right? So can't keep them all easy all the time. So if we are looking at this one, what it says is let's review our exponents. When working with rational exponents, you should use the properties of exponents to simplify. For example, 4 to the 5/2 is going to be written as 4 to the half times 5. So we're going to keep, because this is telling us to find the what of 4, that just means the square root of 4, right? That's what the half power means. So, square root of 4 is 2. I take it to the 5th, I get 32. So if we are looking at this next one, 64 to the 2/3, we're going to rewrite it as 64 to the 1/3, and we're going to put it to the second power. Does that make sense? We're going to go 64 to the 1/3, that whole thing to the second power. If you're not sure, still write it down. 64 to the 1/3 simply means, if we are looking at that, that means the cube root of 64. That's what this means, okay? It means the cube root of 64. What is our cube root of 64? You gotta write this down so you're gonna be with us at the same point, right? So even if you're not totally understanding it, you gotta write it down so when we go on to the notes, you have yours. Cube root of 64 is 4, right? One number times itself 3 times gives us 64, 4. That's to the second power, so our answer is going to be 16. Cube root, that's what 1/3 means, okay? So by looking at the denominator, that's telling us our index or our root, right? This denominator, here when it was 2, that meant square root. So this one, when we look at it, we're going to rewrite it as 81, not to the 5/2, but 81 to the half power is how you're going to start, right? 81 to the half raised to the 5th. 81 to the half raised to the 5th. Next, you will say the square root of 81, or 81 to the half, which is 9 to the 5th power. That's when you want to use your calculator, right? Most of you 9 to the 5th, kind of ugly, pretty big. 59,049. Okay. So, try right now without your calculator and see how you're doing on your memorizing.